Welcome back. Today we will look at how to solve inequalities using graphs. So consider the inequality x squared minus 4 is greater than or equal to 0. Using the rules we've got so far, we can add 4 to both sides and we can get x squared is greater than or equal to 4. But what can we do with this? So if we ignore this for now and look how to solve it algebraically later, but look at it on a graph first. So on a graph, this equation, so it's just a quadratic graph and move down the y-axis by 4. So we know it crosses here, here, and here. And this is the y equals 0 line. Our inequality tells us that we want the graph of x squared minus 4 to be greater or equal to 0. So that is the y value greater or equal to 0. We can see that this is y equals 0, this is negative, and this is positive. This is where it's greater or equal to 0. So we need all of this part and all of this part of the graph. So x is greater than or equal to 2, and the part where x is less than or equal to minus 2. Equals because it also says it wants it equal to 0. If we needed, on the other hand, x squared minus 4 to be less than or equal to 0, we would want this part. So it would be the joint inequality. So that's just a side note if the question asks that. So going back to our original question, we think about the equation x squared minus 4 equals 0. So think about it like a normal equation, regardless of the inequality. So we can solve this for the roots. So when y equals 0, where x squared equals positive 4, x equals the positive or negative square root of 4. So then x equals 2 or minus 2. Now we already had this on the graph, minus 2 and 2. So we get a similar answer and we can see the desired area from the graph. So that's our answer. For a harder example, consider the inequality x squared is less than x. We want to find the region of x values satisfying this. So we can look at this as two graphs. So you have the graph on the left hand side of y equals x squared, and on the right hand side is y equals x. So we want the region of x values where the graph of y equals x squared falls strictly underneath, so strictly less than the graph of y equals x. So we draw both of the graphs. And that's y equals x squared, and the graph of y equals x. So we want the graph of x squared to fall underneath y equals x. So that is this region here. We want that region of x values. So here we can already see that one of them is x equals 0, and we need to work out what this other one is here. So we know that this is the intersection of both of the graphs. So using simultaneous equations, we have y equals x squared, y equals x. If we make them equal to each other, so x squared equals x, and minus x off both sides, and bring x out. Here we can see that either x equals 0 or x minus 1 equals 0. Therefore, if you plus 1 on both sides, x equals 1. So we already know our x equals 0 point here, x equals 1. So our region would then be between here, so between 0 and 1, and in the original question we can see there's no equal. They don't want the exact points 0 and 1 where they're exactly equal to each other. They want the points where it's strictly underneath. So these sides. To follow on, it's important to realise that not all inequalities have solutions. For example, take x squared is less than minus 5. Again, take this as two separate graphs. So you get y equals x squared or y equals minus 5. Draw the graphs. So this is y equals x squared. And this is y equals 0. And this here is y equals minus 5, crossing at minus 5. We can see at no point in the whole of the graph does x squared fall below the graph of y equals minus 5. So there are no solutions. We can say that there's no solutions, or the set of x values satisfying the equation is the empty set denoted like that. As learned in our previous chapters, our next chapter will show us how to solve these equations without graphs.